I'm Cliff Hall, and today I'm going to show you how to go about creating a plugin in Sinewav. One of the easiest ways to go about it is to look at Three.js examples that exist on the web and see how to convert them into Sinewav plugins. So we'll take a look at one of those right now. One of the best ways to get started is to look at the example plugins. All of the API functions are exercised in the example plugins, and every time a new API function is rolled out, there will be an example that will show how to use it. So today, let's copy the tentacles plugin, and you can see that this is a Three.js example. Hierarchical geometry, and we will take a look at this code briefly and just see that like most demos of Three.js on the web, they do some setup. They'll add an event listener to move things around. We don't really have to do a whole lot of the things that happen in a demo. We can really just boil it down to the essence of creating and manipulating the objects. We don't have to do any of this listening stuff. We don't have to create the DOM elements. We don't have to create the camera even. That comes with the scene. So really, we just create some geometry. We create a material for it. This is the mesh normal material that gives each face a different color based on the direction of the normal of that face. And create a mesh with the geometry and the material and add it to the scene. And then go about making these tentacles, these that go off in X positive, negative, Y positive, negative, Z positive, negative directions, that we go down through there and we parent each box to the one before it. And by doing that, when rotation gets added to the parent, it gets added to the child. And that's part of the way the tentacles whip around, we'll see. We don't have to create a renderer, and we don't have to put that into the DOM or have window resize listeners or any of that sort of stuff in Sinewav. We don't have to worry about managing the animation frame. All we have to do is write the setup code of what's going to go into the scene and write the render code for what's going to happen each frame. And in here you can see that we get a time value, and then we use that to create a random rotation that is sinusoidal in nature, and it will set the camera position based on the mouse, but again, we won't do that in Sinewav. It goes through the object, it traverses it with the object 3D traverse function from Three.js, which you're probably familiar with, and it goes through all of those objects that were created, all those parented boxes, and gives each one of them this new rotation value. And remember that rotation compounds as it goes down the length of the tentacle, and that's what the crazy whipping effect comes from. And it calls render, but we don't have to do that. Let's take a look at how this boils down in Sinewav. In Sinewav, we've exposed some settings here in X, Y, and Z position and space so that we can move the tentacle object around. And we have a setup function, and you'll recognize this setting of the root position based on X, Y, and Z. And then we'll have this, and we're doing this in a function that isn't being invoked in setup. It's being created and stored on the memory object, part of the context. By the way, you can always get to the documentation about the context right there while you're writing code, and see all of the things. The memory is just an object onto which you can create functions, you can create values for later reference, and you can that way have most of this heavy lifting of your functions defined before you get to the render. So the per frame render, the JavaScript code is as light as possible. You have to create the function and then execute it. So we create that box geometry, we register it with the context, and that's necessary so that Sinewav will know about this geometry and be able to free it later. Same with the material. We create it, and we register it. We're giving it a name, we're giving each of these a name. That's just in case we wanted to refer to them later. We could be creating stuff in the render function if we wanted to, using pre-created geometry and material. And so we create a mesh with that geometry and material, and we call that locate function, and we place it in space, and we save a reference to that object on our memory so that it's easy for us to get back to it. We could retrieve it by name, but it's just as easy to hold on to a reference in memory, and that'll be free later as well. And we call context.add_to_scene to actually add the object to the 3D scene. We don't get a handle to the Three.js scene in Sinewav. We do that through the API so that the API can track everything. And notice it wasn't necessary for us to register the object. The object was registered as a process of adding it to the scene. So later on, when we're destroying the visualizer, Sinewav can actually remove the meshes that were added to the scene. It can free the materials, it can free the geometry that would be otherwise in the GPU. And so we go about, we're still in setup, and we go through all of the objects here, and we do the same thing that was happening over there in the demo. We create this parented hierarchy of boxes going out in every direction from the root one. And then in our render function, we do what was happening over in that demo, as far as basically exactly the same, except for having to deal with the camera. We're going to go ahead and set the rotation. We're going to traverse the root object, and we're going to set the rotation on all of the children. Remember that compounds as it goes down each arm, since it's a parented relationship, and that causes the whipping effect. So we're also calling memory context memory.locate. We did that up here as well as soon as we first created it. We go to projects, and we create a new project, add a world, add our copy of the tentacles. We can see that it positions it in space to begin with, but during the time that it's being visualized, we can actually change its location. Well, that was easy enough. I hope you'll dive right in and learn how to develop plugins for Sinewav. As you do, be sure to like the plugins that you learn the most from, and read the plugin API documentation, join our Slack discussion, and as you learn, publish plugins as examples that others can learn from as well. So I hope you enjoyed the video. Look out for more in the future, and thanks for watching.